We're going to go over these properties of logarithms. If I have a base a, you see that base, and I want 1, I'm going to have to raise the base a to 0. Okay? That just makes sense, I hope. Anything to the 0 power is 1. If I want my base to be itself, then the answer to the logarithm, the answer for the exponent, a logarithm is an exponent, then I'm going to have to raise a to the first power to get the same thing, a. So hopefully that also makes sense. If I say I want the base a to be a to the x, then I'm giving myself the answer. If I want the base to become itself to the x power, then guess what? The answer is x. Because anyway, I'm telegraphing what I want there. And then if whatever I raise a to, whatever that exponent is, there's some exponent. We'll call it, I don't know, what do you want to call it? M? A to the m. So the log of a, the log base a of x, and it's equal to, let's see here, can't write, to the log base a of y, then I really don't need 2 letters, and I mean, I guess I could say that, but if the exponent is the same, then, you know, they must be the same, because, anyway, hopefully the one-to-one property, I don't think I did a good job explaining that, but if the exponents are the same and the bases are the same, so they're equal to each other. You see they're equal, right? Maybe I should use that color. They're equal to each other. So the exponents are equal. That's what they're telling us. And we can see for ourselves that the bases are the same. Okay? If the exponents are the same and the bases are the same, then x and y have to be the same. Okay. So let's see. We can solve x. So there is some exponent for 2. I guess I'll call it m. For which I will get x. And there's some exponent for 2 if I want it to be 3, will be the same thing. So using the one-to-one property, I know that x must be 3, so there we go. Solve for x here in this situation, the second one. If I have my base is 4 and I want 4, then I know that x is going to be 1, right? X has to be 1. Okay, so we're just using these properties. Let's see, if I have my base 5 and I would like it to be 5 to the x, then I'm telling myself, hey, it's x, okay? Whatever x is, that's going to be it. If I just write it out with an exponent, then I know what the exponent is. It's kind of silly. And then this is interesting. If I say 7 to the log of base 7 of 14, well, it's raising 7 to an exponent, which is good because the logarithm is an exponent. And this logarithm that I've highlighted says there's some exponent that if I raise 7 to that exponent, by that exponent, I will get, let's say it's m, I will get 14. Well, I can skip all that and just get 14, right? If I don't even have to know what the exponent is. I don't know what that exponent is, but I'm raising 7 to that exponent, so therefore I must be going to get 14 without knowing what the exponent was. You know, it's not 2, that'd be 49. It's not 1, that'd be 7. It's something between 1 and 2, but I don't care. So, all right, so let's see. Use the properties of these logarithms. So, I've got These are equal. So for 31, I have a base on both sides, and it's 7. And I'm going to raise it to some exponent. I don't know what the exponent is. But when I raise the one on the right, I'm going to get 9. So I'm pretty sure I'm going to get 9 for that, so I know what x is. So x is equal to 9. Has to be. If they're equal, if the bases are equal, and the bases are equal, okay, then x must be the same too. It has to be, right? Okay. Then I look at this next one and I say, what's going on here? If I raise 4 to some exponent, x, I'm going to get 4 to the 2, right? I'm going to get this. Well, I already know what my base is, and you're telling me what the exponent is, so guess what? X equals 2. It has to equal 2. What else could it be? You said if I raised 4 to the 2, that would be my goal, and I know the base, so therefore the exponent's 2. It's kind of double talk, I guess. Hopefully that's simple enough not to be confusing.